Hey, hello there. Today I'm looking at the question 850, rectangle 2. So the question can be pretty much summarized with a single image here. That's what the question provides. We have a 2D plan and we got a bunch of different rectangles. They can have different size, they can appear at different places, and they can have overlap with each other. The question is asking us to calculate the total areas that are captured by those rectangles inside this 2D plane. So that's the question. So as an input, what we have is a list of tuples where each tuple contains 4 numbers, x1, y1, x2, y2, and x1, y1 is the coordinates for the bottom left, and x2, y2 is the coordinate for the top right corner for the rectangle. Because it's rectangle, given 2 numbers, we can figure out the every edge is kind of parallel to each other, so to the other 2, I guess, to the other edge, and perpendicular to the other 2 edges. So you get the idea. Having those 4 numbers, we can figure out the area and location for that rectangle in the 2D plane. So now our question is to calculate the total area. Obviously, we want to remove all the duplicate. We don't want to double count the duplicate. That's where the challenge is. So how we go about and solve this? So let me try to illustrate this with a plot here. So we have 3 different rectangles here. To make the problem a little bit more complicated, I have that to be separated and also have some and also the rectangle are not in the same quadrant, so making the problem slightly more generic. So let's just imagine that we have a line that we can use to swipe through this 2D problem space, and we will trigger this event when we are at the left hand side, left edge, left how you call it, side, I don't know, of this first rectangle that we have. It will trigger an event saying that hey, from here I have openings. And then during the process, I'm swiping through this space. Depends on how far away I'm swiping from the prior event triggering X position. I can basically say that the opening, the size of the opening interval multiplied by the length that I have traversed doing this line swiping, that area basically I can say once I pass that the area here, sorry, why is that let me do black. So once my line is with my line swiping through this 2D space, I can say that the current opening multiplied by the length through the last event has been realized. I can add that to some kind of total, and then here I'm triggering 2 more events because my opening has become a little bit more complex. I have 0 to 2 and 1 to 3 and also -1 to -2. But that doesn't matter. We can just remember those openings and keep swiping. Now at this position, we will trigger another event at this time. So we can say that through the time between this event and the previous event, I'm just gonna realize all the openings that I had and calculating the areas and add that to the total. So we're basically gonna mark those little opening multiplied by the path I worked through since last event, adding those to the total, and then just keep moving. You get the idea. Once I pass the very last rectangle, if I do this according to the way I'm describing, I pretty much added all the areas together and there is no double counting. The slightly difficult part is basically when I were, so that will be the case here. Let me try to show it. When my line is triggered by an event at x value 2 here, my opening is looking like the lines on the right hand side. So for the openings, we have 3 different line segments, and so I need to know how long it is. You know, how much I can multiply the by the you know, horizontal length I have worked through from the last event trigger. So I have to basically find something to multiply one to mark the four little you know, the one area here and the other area here, add the number to the total area. So how do I get this? If I transpose this kind of opening, you know, from 0 to 2, from 1 to 3, and -1 to -2, flip that over to be horizontal, it seems like it becomes another line sweeping problem. So we're basically just going to swipe this from the bottom minimum, you know, deep down in the axis, and swiping towards the high end, and see, hey, we have a line segment of length 1, and then we have another line, two line segment, but they overlap, so they can combine to be of size 3. You know, that's pretty much by moving this down, so that collapse those two intervals into one longer one. So the length for that longer one is 3. So in total, I have 4 units. And how far I have moved in the horizontal, that is 1. So I multiply 1 by 4 and add that to the total. That's equivalent to say that I basically am marking those things, adding those areas to the total. So now we see that this problem basically becomes a combination, a nested swipe line sweeping problem. The parent line sweeping is one direction. The other one, the other one is in the, you know, perpendicular direction, the other direction. So it's those two combined. And the event here basically is we encounter the left-hand side of the rectangular. That's when we add this you know, y1 and y2 to the current open. And the other type of event is when we swipe the line through the end of that rectangular. We want to remove the open 0 to 2, in this case I'm showing here, from the current open. Yeah, so that's pretty much the solution. I'm just gonna try to code it up really quickly. Yeah, so we convert this rectangle into 2 types of events. So that's the first part. Convert list of rectangles to events, and then we have a helper function to do total interval length calculation by not to count the duplicate, but you know, just return the total as the right hand side line swiping showing you what shows by there. The third thing is to do the bigger sweep line to calculate the area. So that's the 3 sections basically. So let's just do this conversion first. So what we're going to put on this here is going to be, you know, that when we do the line sweeping to trigger the events, it's triggered by the X position in my illustration here, and there are 2 types, open and close. So that's what we need for the event, and for every event there are 2 types of information, the y1 and y2. So that's going to be either add to the current open or remove from the current open. So we have to put four elements on as an event. The X position where this event is triggered, the type of event, and also the size of the open that should be added or removed. So that's 4 elements. X1 is going to be open. Let's just put open as 1. Just comment what's going to be on there. tuple of x type y1 and y2. So the closing event is that it's indicated by 1. Because we want to sort them, we want to sort this based on the x position and then by open and close. Yes, we want to do by open and close. Does it matter? I would try that, but here for simplicity, I would sort first by x position, then always deal with open first. I will figure out does it matter if we do the closing matters. So the reason we sort is basically we want to enumerate over all the events. So that would basically simulate this actual line swiping. Otherwise, if we don't sort, then it's not guaranteed that we are processing those events in the order as the line swipe. So that's this event processing. Then we're just going to do this. Area is 0 in the beginning, and the previous triggering is going to be in a variable here initially to be in minimum. So that's where the line coming from. It's from the far left, super negative number. Just gonna put two things here. Modular, which is gonna be 10 to the power of 9 plus 7 per the question requirement, and we have interminimum. So initially, the previous event triggering position is the interminimum. And then we have a list of open events, open intervals. Going to be initially empty as well. So we're just going to do event in events. When the event is triggered, the first thing we do is to try to paint the past rectangles portion to be black and add the number to our total. So we're gonna do a helper function called maybe some kind gain area maybe. By what do we need? We need the previous event trigger and the current event triggering position. That's going to give us the one of the multiplier we do, and the other thing is the current opening. If we define the function here, then it has direct access to this, but we still need to pass in two numbers to it. So let's just call this gain area. It will need two things: previous and current. And it will return the area we want to add. So we're just going to add area to add this function call to the area, previous and current. So let's just unpack this. Every event, the first element is the current position. So it's current type close, because close is 1, and y1, y2. Unpack this from this event, adding that to the area, then we deal with this event. If close, if it's closing, we will remove y1, y2 pair from the open intervals. Otherwise, what we would do is to add this to the interval. And we will want to sort the open intervals. The reason being that the helper function, we're basically going to do this line sweeping to calculating the total area. So we're given the multiplier basically as the parameter to this another smaller line swiping. Whenever we swipe through a line segment, we want to multiply the length of the line segment with the multiplier. So let's go back and code this up. So it's going to be area to be 0, and the previous is going to be interminimum. That's when we swipe through, after flipping it looks like from left hand side, but actually this will be from bottom, from negative on the y value and up in my example. So I'm just going to do this for left and right in this open intervals. We're going to update this previous position to be the maximum between the current one and the previous. And whatever the difference between the right hand side, the right, and the left, the previous left, it's going to be, if we swipe through here, we update previous to be the left pointer here, and we look at the right hand side. The difference can be multiplied by the multiplier and add to the area. So that's going to be right, subtract the previous, and multiply by the this current. Let's put x here so that I don't, or I can just put a multiply here. So instead of passing this 2, I will pass the difference. And then after I swipe through this, I might encounter a smaller, a special case, I guess. I need to handle the special case when one line is longer, and then the other line basically is embedded in there. And we're going to trigger an event after the area has already been multiplied. We need to avoid that. So after we trigger the event from the left hand side, we're going to update the previous to be equal to the minimum, equal to this maximum at the right hand side, so that when we trigger the event from the inner line segment, we're not going to be doing this addition. So that's handled by, after we do this area realization, we move this to the maximum between R and the previous. So so when we encounter the inner line segment here, this line doesn't change the previous value, but we want to have this to be 0. So this will be negative because the right hand side of the inner line segment interval is less than previous. So that's the difference between here and here. That's negative. So we're just gonna max it, take a max between 0 and that. So that effectively cancel out avoid the duplicated calculation for the area. So that's that. Yeah, that's pretty much it. We're just going to return this area. And after we process the, so back to the main sweep line algorithm. After we process those 2 events, what we're going to do is to updating this previous. So that's pretty much it. Let me quickly check for problems. I shouldn't initialize this to be interminimum. I have a better prior. I can sneak peek into the first interval and just grab the left-hand side from there. Because otherwise this will be crazy. This difference will be crazy, but it's not. But it shouldn't be realized. I guess it wouldn't, because the open interval at that time, the first event, it will be 0. So it will be 0. Do I need to? Let's just try this. I'm so bugged by the birds there, and also my kid. It seems okay this for this example question. Yeah, let me try to sort this by the negative order to see if that changes things. Not really. Okay. Does it matter if we handle open first, then close, or close first, then open? The area realization, adding the swiped area to the total doesn't really matter. But if we have situation like it just open and close at the same time, we would definitely want to do close first and open second. Otherwise, does the remove one more? All occurrence or just one? If it's remove one occurrence, it's fine. But if it remove all the occurrence, it will be problematic. But safety, to be safe, we can just do the remove first and then do the add. So if we want to do the remove first, we want to sort this by have the closed to be first. So since close is 1 larger than open, we can actually sort this by the inverse for that. Yeah, so that makes sense. Let's try submit it. No, it's not working. I got a really big number, but here it's 49, and it just I need to do the modular. I really have to run. Anyway, let's try this time. Yeah, okay, it's accepting. So that's this question. It's two line sweeping approach pieced together. We have the bigger line swiping to to try to color the rectangle parts, mark those as areas we have already visited, so we add that number to the total, and each individual event, before each individual open and close event has been triggered, we have a smaller line sweeping problem to add the calculating area. It's the multiply by the horizontal lens we worked through with this main line swiping, and the total length for the can potentially overlapping opening intervals that we have. So it's two line sweeping problem fused into one. And in the line sweeping, in the smaller line sweeping, it's actually more challenging because they have this this special case you want to handle. And I guess the order here, I need to figure out does the remove one or remove all. But for safety, we always do the remove first and then do the add. So in that case, the order, if we process the events in that order, we will always be able to have the correct opening intervals on this list here. Yeah, so that's the question. I have to go. Oh, sorry, the time and the space analysis. How to do that? So let's say that we have n different rectangles. So the size of the events will be 2n. So this loop here is 2n. And each of those loop here, we can see that we want to go over all the intervals in this Gantt area call. That's another for loop. So it's n squared. So it's n squared. But we also have a log n sorting here. So how much is that really? Is it n multiplied by n plus log n? That seems so. So we have n, this bigger parent loop. Inside each loop we have this function call, which is another n. And then after the function call, we can potentially have a sort. Oh, sort is n log n. Sorry. So it's a n squared log n in time. So that's. So the two multiplied together, we got the total runtime to be n square root of n. So that's a runtime. I have to go.